Hello everyone, my name is Lakshan Purbe and this is Lab 3. The purpose of this lab is to observe the relationship between the distance dependence of the magnetic field of a bar magnet. We use the Beer-Savart law to calculate the magnetic moment and then use VPython to simulate this and compare the two values. The two fundamental principles on this lab are the Beer-Savart law that we use to get the magnetic field and the distance dependence formula. The experimental setup of this lab is as follows. The system is the magnetometer in the phone, and the surroundings are the bar magnet and the Earth. We assume the bar magnet acts as a magnetic dipole. For the experimental model, there are three parts. We start off by finding the location of the magnetometer on the phone by sliding the phone on a ruler perpendicularly. We do this both in the horizontal and vertical direction. To do this, we place a magnet at one end of the ruler and find the position at which the phone and the magnet have the strongest magnetic field and mark this point with the tape. Thereafter, we proceed on to get the on-axis distance of the bar magnet to the magnetometer. We use a ruler and different magnetic field values. For this, we first place and leave a phone in such a way that we get the x component as 0, ensuring the Earth's magnetic field does not interfere. Thereafter, we linearize these values and graph it. My experimental results are as follows. You can see my graph here as well. For the third part, we proceed to find the off-axis magnetic field. We first found the on-axis distance from the phone, so the magnetic field was 100 microteslas. We then move the phone vertically the same distance and record the components of the magnetic field at this point. To get the y component, we subtract the Earth's component from the total component. The observations we made were as follows. When the magnetometer is far away from the magnet, it measures in a zero magnetic field in the x direction. As the magnetometer moves closer to the magnet, the measured x component of the field increases. The position of the phone matters in terms of ensuring the magnetic field of the Earth does not interfere with our readings for the magnetic field of the bar magnet. In order to do the calculations, we linearized our values and got the equation of the line as y equals negative 3x minus 14.572. We then use this equation to get the value of n and k. The value of n is the slope of the graph, which is negative 3.0046, and we then use the y-intercept to get the value of natural log of k, and then proceed to find the value of k as 4.693 times 10 to the negative 7th. We then use the Beer-Savart equation to equate the equation to the distance dependence equation and get the magnitude dipole moment, which is calculated to be 2.347. For the coding part, I first put my value for mu as 2.347 over here. I then define a function for a magnetic field at any given point from the magnet. Thereafter, I created observation locations and created arrows at these locations to represent the magnetic field at these locations. I then created an arrow representing the magnetic field at location 45 degrees off an axis using distance found in the experiment. Here are the computational model and the calculated results. For the off-axis magnetic field, I found the theoretical value to be 2.92 times 10 to the negative 5, and the experimental value to be 6.35 times 10 to the negative 5. This had a 74.07% difference. This could be due to many reasons. The magnetometer location could not have been located or more precisely, which would have affected the results for the distance. There could be the possibility of the readings for the magnetometer before the experiment not matching the magnetic field of the Earth. This would affect the off-axis values. What if you hadn't oriented your experiment to compensate for magnetic north and had instead laid out the meter stick at some intermediate angle with respect to Earth's magnetic field? How would your results have changed? The x component that we would have measured would have all have changed by the same specific value, and the percent difference between the theoretical and the experimental values of the net electric field would even be magnetic field would even be greater. What if you were to stick two identical magnets together, end to end, and run the experiment again? How would you expect your measurements to differ? The measurement would all differ by the same scalar constant by which they would be multiplied, and the dipole moment would have been completely different. Thank you so much for watching.